Hi, and welcome to this video. We're going to cover a requested question in the subject of statistics, which has to do with one proportion or one sample proportion hypothesis testing. Now, the real focus of this video is to understand how do we take care of the testing, the computations, all of that within Excel. You're going to see me jump around a little bit between this program and a calculator that I use um, there's actually two other, another one I'm going to bring up too. I just realized, but a couple of different calculators just to cross-check and show you a couple of things related to this type of problem and the way in which we're going to set up and solve it. But again, is really going to be focused in Excel. So let's start with reading the question and then we'll get into all of that. So it says that a tire manufacturer claims that more than 85% of the company's tires will last at least, so 80,000 or more in kilometers. In a random sample of 400 tires, 22 were worn out before reaching 80,000 kilometers. They want to know, does the data of, I guess, in this sample support the manufacturer's claim with a level of significance of 0.01. And remember though, even though like you could type A if if you're not able to retrieve the alpha symbol, it's alpha, right? Now, there's number of things in this question that I kind of found tricky. And the first thing is actually to do with the hypothesis test, or let me say statements, okay? It just starts off with the claim. Now, bear in mind, the claim is the thing that's consistent, okay? We're going to absolutely test this claim, which says more than 85% and it's at least 80,000. So clearly this is saying it's a left tail test. Sorry, right tail test. You'll have to excuse me because I've done this video two times before already, so just bear with me if I make any like anyways. So because I've had some technical issues. Okay. So anyways, it's a right tail test to just see if the evidence here supports this claim of more than 85% of the tires lasting well over 80,000 kilometers. But the issue I had was, again, just how do we set up the hypotheses themselves as like the guide post, for the rest of the testing. Because at the end, we're going to have to make a decision and then summarize related to whatever is the claim. So, of course, this is an important part of the testing process. And I do want to just make a corrected statement because I may have said this in another video that, quote, it's the null hypothesis is always equal to a value. And that's actually not necessarily true because even though we see a lot of the times, the null hypothesis is shown to be equal to a value to represent no difference from a particular value that's been the standard, quote unquote, or standing. We can actually say for a particular scenario situation that the null is something else other than equal to, like greater than, less than. So that part I'm going to leave up to your discretion because, again, I am only working with the information here provided by the original post, the student that posted this. So please just bear in mind that this is what I have, and that given what you've been learning in the class and how your professor has gone through problems like this, whether they're writing the questions or they're taking it from some type of learning material, this is up to you at the end of the day to decide how you want to solve the problem. So I'm here to guide, I'm here to provide suggestions, and you can take it or leave it, because this is your work at the end of the day. Now, I give here two suggestions, but again, the claim, because that's really the focus, right? The claim is absolutely consistent. And this is why you see it highlighted in yellow, that we're going to test that particular claim. It's a right tail test. So you picture the curve, or if you've already drawn it for this problem, then you can see that the area is to the right of this value. Well, the value that's going to be the p hat coming from the sample that we're going to use to test the claim. Now, speaking of the sample, this was the other little tricky piece, which was the information they provided. They say that of this random sample, 22 wore out. Like, wait, wore out before, even though we're talking about at least going above 80,000 kilometers. So which one is it? Well, the claim is asking about more than, and I would think that because we've seen it time and time again, I would think that the p hat value would be close to the null proportion, which in this case is 85%. So that's also a consistent thing. So the first time I worked through this problem, I actually just did 22 as given and divided it by 400. That gave me a value of 0.055. Okay, that's really, really low compared to what they're usually dealing with in the company. So I figured maybe that's not the value we're using. We're probably not going to use the number 22 because it just does not align with what they're talking about in the first sentence. And usually the first sentence, first couple of sentences before they get to the sample really sets the tone and the stage for what you're going to be dealing with, how you're going to be setting things up. So what I decided to do is I actually found the complement to 22. Maybe the 22 is, let's go back to binomial probability. Maybe this is the failure. That's probably not the focus of the study. Whereas the success, 378, is what we're actually going to use for X. Hopefully that makes sense. Again, just calling back to binomial probability. So with that being said, I got my p hat, my sample proportion, to be 0.945, which is clearly, more than 85%. It just wouldn't make sense too if we had 0.055. It does not align with trying to, support the manufacturer's claim. So if that's of the original question, that's probably not the number we use to calculate p hat to then calculate the test. So now with all that being said, we're going to move into how do we use Excel to find the test statistic, find the p-value, and then ultimately make our decision at the end. Keep in mind, Excel does have a lot of stuff going on. It is great for statistical, analyses, and specifically, it is just another calculator. So it's a really big calculator with a lot of different functions within it. But you can also do really simple operations that you could write out the whole equation. For example, p hat, I could just do that in my calculator and type it into the cell, but instead, I actually did the operation right here. Anytime you're doing a function within a cell, you're going to typically type the equal sign, or let's say you're choosing from a table here, okay? You're going to just choose that and it'll come up as equal, blah, blah, blah. So bear in mind that anytime you want to do a calculation, use an equation or function, there's probably going to be an equal sign that precedes that actual function. So there you see p hat is taking the x value and dividing it by n. I had n listed first and then the x, so that's why you see B7 over B6. You can flip it if you want, it doesn't really matter. So long as you have it set up correctly for what represents p hat. And that really does lead into the z-test. The z-test, I ended up actually writing out the equation, typing it out in the cell to calculate the z-test because there is a z-test function. Let me just show you what it would look like. And this is another way to pull up the functions. I'll just probably say all this again in a little bit. But in their list here, here's the z-test. But notice it what it's asking for you to provide is asking for an array. And an array is just another word in Excel used to represent a set. So it's a list of numbers that you would select, and that would come up alongside the function. And then you would have to provide an x value, I guess, let's see, I guess the particular X value that you want to convert to a Z test, and then the sigma value for the population related that the sample came from, right? And it tells you what it's going to provide or what it's going to calculate, right? It's going to return the one-tailed p-value of a z-test. So, and all in the little things that you provide in that, all that's going to happen in that is going to simultaneously calculate the sample mean, the z-test, right? And then using the x value that you provide. So maybe the eggs is something else now that I think about it. But and all of that to say it's going to provide the p-value. It's not even going to give you the z-test. It's using the z-test to provide the p-value, right? Because the z-test and the p-value are connected. The p-value is the area related to the z-test. Now, coming back here, I just wanted to type out what the z-test looks like so that you understand how I typed it out. So the z-test, I'm just going to use a bit of different typing here, but the z-test is the sample proportion minus the population proportion, right now the null, and that difference is being divided by the square root of p times its complement divided by n. So this should look familiar. This is again the z-test for the proportion. So in Excel, this is what I typed out, pretty much that formula using the values that I have here and then some other ones I just calculate to the side. So again, because I have the values listed in the spreadsheet, I can just select those cells and bring them into the formula. You can also type the numbers themselves. That's totally fine. And they'll know what to do with that. Again, it's a calculator as well. But you can just literally select cells if you have the values already within it. So there you can see in parentheses B8 minus B4. So that's P hat minus the null proportion divided by, after the parentheses. Square root is a function built in, so that's why you see it capitalized like that. I type out SQRT, knowing the function that's the symbol, and then it comes up to then receive the information. So in parentheses, I have parentheses 0.85, that's the null, times its complement, 0.15, divided by 400. And I think this right here, it finally hit me. This right here actually should support why we went with 378 for X rather than 22. 22 again represents the number of those tires that wore out before reaching like the threshold. The claim that the manufacturer has is dealing with those tires that can go beyond it. Already 85% of the company's tires can go beyond 80,000 kilometers. Again, it's the phrasing at least that suggests that there's more kilometers that the tires can go through, right? Does that make sense? So the manufacturer is like, well, maybe it can be more than 85% of the tires. So to say that the 85 is the proportion of that means that the 15% are those that wear out before reaching 80,000. So I think it would just not work out well if you use the 22 as the X, the number of successes that represents what the claim is, the focus of the study is. Okay, so again, I think it was just really tricky at that point. Maybe that cleared up some things, hopefully. Okay. And yeah, going back to this formula, we have that product 0.85 times 0.15, and then you divide by 400. So again, you can type out the entire function or equation. Just keep in mind the symbols that you can use to do those basic operations, the big four, right? So you have your plus sign, you have your hyphen for the minus sign, the slash for the division, and then the little asterisk here, above the number 8 for multiplication. So with all that being said, you have that, you click enter, and it calculates immediately for you that the z-test is 5.321. Again, I had actually just checked beforehand on this calculator, and this is another web-based calculator that's really nice and helpful. I've probably previewed this or shared this before in other videos, and rcbuddy.com is the link You can go to just about any part of it, and always you'll see a drop down here, and you'll go to hypothesis testing and choose the one that's the parameter that you're focused on, the problem. So in this case, we're looking at proportions. So we're going to talk about the inference for the proportion, right? So you plug in everything. We have a one sample since we're only dealing with values of one set. The piece of 0 or piece of O, that's your null, and that's the 0.85. The alternative statement here, this is, the type of test that we're doing. And unlike the TI-84, for example, which shows what's to the left and right of the inequality, this one doesn't show that, but just keep in mind, it's probably saying the sample proportion. Then you have the greater than symbol, and then to the right of it is the null. So that's always how we're gonna, look at that in these sort of calculators. And then, of course, we're not including the confidence interval. Then we get to the bottom here, the last part. You're going to either provide the count of the sample size and the successes, or provide the p hat. You can provide the p hat, but just to be careful here, especially if it's other numbers besides these, I like to just provide, the sample size and the successes to get the most precise p hat, to get the most precise test stat and p value. Then you click calculate, and it provides the results to the right. So we see our test statistic, same thing, 5.321. And then we see there the p-value is 5.18 times 10 to the negative 8. So a lot of zeros in front of that 5, which makes it virtually 0, okay? And that's pretty darn great for this manufacturer as a way to show it supports their claim. But we'll get to that in a moment to really wrap things up. Last part in understanding how to use Excel and as it leads to the decision making is in finding the p-value. We're definitely going to use one of those functions. And so again, you can click on this function button right here, always to the left of the big text box. But you can also go to the formulas tab. I'm using the web browser version of Excel, but if you have the desktop version, you should have the formulas tab, especially if you have the most up-to-date Microsoft Excel application. And what's really great is inside of it, you have these categories of functions. And when you click on more functions, if that's the case, you'll find the other categories. So just always look for statistical when you're doing these sort of things for statistics. And you're going to look for norm, okay? Because again, I don't know why, oh, there we go. Again, for the proportion, you're always using the Z distribution. So we're going to use norm, the ones that are labeled norm, to deal with that. And there's two of them here. So you have norm dot distribution. You can see there for the description of it, it tells you what you have to provide. X would be p hat. The mean would be the null proportion, because thinking back to sampling distribution, whatever is the mu of this normal distribution is also or is equal to that proportion of the population, which at the moment we're saying for the null is 0.85. Then you have the standard deviation, which would be the standard error of the sampling distribution proportion. And that, let me just go to Desmos, well, it's actually right here. This, let me copy, paste. Okay, so I'm just gonna get rid of that. So what's underneath, what's in the bottom of that fraction right here, that is your standard error for this proportion sampling distribution. Okay, so that would be the quote unquote standard deviation that you would plug in. Okay, so, just looking at it as if it was a mean, but instead we're dealing with the proportion values. That's why sampling distribution was a big deal. Okay, you should at this point have covered that. Last part in this is cumulative, which is simply, is this area you're looking for a cumulative set, meaning going up to that value that you're, estimating here as an area. The norm.s.dist, that's standard standard distribution for a normal distribution. And it looks a little bit easier. You do have to calculate the Z separately, and that's what we did here. And then you would again choose cumulative, yes, well, they'll ask you to type true, or if it's not cumulative, you'll type false. So actually show two different ones because you can use either and you do get pretty much the same answer. Okay. This one's written out in standard number form. This one is in scientific notation, but it's the same. So you can see how I had typed in there 0.945, 0.85, and then 0.01754. That's your standard deviation. It even highlights that. That's kind of cool. And then the last part is true. Now, before getting into all of that, we need to understand for this claim, what exactly is the setup for the p-value? I'm actually going to do this to lower part of here because it really depends again on the type of test, right? So if it's left-tailed, all you have to do is find the area simply like that. And that would just be the norm, say equal the norm dot s dot dst, right? You would just provide the z-score and then say cumulative is true because it's going up to that z-score. Notice the symbol that I have there in that probability statement, z up to z, whatever that z-score is. Now, if it's to the right, you're going to have to do 1 minus that. So yes, technically, what we're looking for is P of Z greater than the Z-score because it's at least 80,000. So with the proportion of 0.945, and we find the Z-test for that, okay, we're representing an area to the right for that test. But because it's, for a lot of these calculators, you have to use the areas to the left of z-scores. You have to actually subtract that area from 1, which represents the total area of the curve. So that is the setup here. And real quick, the last one, the last case, two-tailed, I've actually seen it as 2 times that, but what it probably would be is the probability up to either one and then divide by 2. Okay, so I would just leave that point there. I'm not going to get into that because that's not the focus of this problem. But we see there, we're going to set it up as 1 minus that area up to the z-score. Now, at this point, you're going to see me do that, just demonstrating again. And there it's already written, but I really want to show you how it comes up in Excel. So the first thing you want to do is you want to put your equal sign. Again, for any function, any calculation you want to do, you have to put equal. And that's going to prime the Excel to know, okay, we're going to do a calculation. After that, we have 1 minus, and then we're going to look for our functions. You can type out norm if you just remember a little bit of the name of it. If not, again, just go to either section, either in the ribbon or next to the text box at the top for the function and look for it. Again, it tells you what it's going to provide. So it says returns the standard normal distribution. This is because you're providing a standard score, a z-score. So it even gives you an example. It's just so nice. So the z-score again is 5.321. You can type it, but I actually just selected it because look at the whole number. Okay, that's going to give me a more precise area to work with, and then I can approximate at the end. It's better to leave the approximation at the very end. All right, last thing is cumulative, true or false. It even explains what it means if you say true or false. Because if they're asking if it's cumulative, they're asking if it's a range that we're dealing with. If it's not a range, we call that the probability density function, which is basically like if you imagine a curve, it's just one line from on that value that you're looking for, that you're working with. Okay, it's not an actual coverage of area, if that makes sense. Okay, so definitely look that up if you need to. But we're going to say true. You don't have to capitalize it. But when you click true, it's going to picture that going up to 5.321, you have that area. It calculates that, and then it's going to subtract it from 1. And that's how we get 5.158 times 10 to the negative 8. Okay. And then we see, okay, well, the p-value is clearly less than alpha. We know that if alpha is, or if p is less than alpha, then that means we're going to reject the null. If p happened to be greater than alpha, then we do not reject the null. Remember, our alpha level is at 0.01, and then our p-value is virtually 0. So absolutely, we're going to reject the null. And then as a way to summarize, we'll say that there is statistically, keep in mind it's all about the statistics here, so we don't know if it's practical. But for now, we can say it's statistically significant, or there is significant evidence to support the claim. Remember, the claim was saying that there is more than 85% of the tires in the company that go beyond, or that can run at least 80,000 kilometers, right? So however you want to word that, but the main part is we say it is or is not significant evidence to support the claim. So I really hope that this helped in all of this. Remember, leaving at your discretion how exactly you want to write the hypothesis statements. I think, though, that X is 378, but again, double check for yourself to be certain. And I hope that things have cleared up for you. And how do you use Excel? I've shared other calculators with you. Again, Desmos, you can just type stuff into the scientific calculator, which is great. So if you don't have like a TI-84, you can always just use their free and open access online Desmos calculator. Also, they have an app. Okay, so definitely let us know if this helped, or if you have any other questions, and we'd be happy to support you on that. And we'll see you around.